you find this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, today our topic is vectors in Rn. So as we know that vector is a quantity that has magnitude, that is length, and direction. So it has both magnitude and direction but not position. Therefore we can put a vector anywhere we want in a plane. So it's not necessary for a vector to start at the origin, or it need not start at the origin. A vector can be represented in point form and a line form. So in point form, in 2D it is defined to be an ordered pair xy, where xy belong to real number r, and in 3D it is defined to be an ordered pair xyz, where xyz belong to real number r. Similarly, in ND it is defined to be an ordered pair x1, x2, x3 up to xn, where x1, x2, x3, x4 up to xn belong to real number r. So in 2D it will have 2 variables, in 3D 3 variables, and ND n variables. So a point is represented by a capital letter like P, Q, R. We mostly represent a point like this, whereas vectors are represented by lowercase like U, V, W, and all these are in bold lowercase letters. Also, points have a fixed position or a static position in a plane or in a space. Now in line form, a vector can be represented by a directed line segment whose initial point or starting point is the origin, and the terminal point or end point is a point as ordered pair xy in 2D, where xy belong to real number, xyz in 3D, where xyz belong to real number, or ordered pair x1, x2 up to xn in ND, where x1, x2, x3 up to xn belong to real number. So vector in line form does not have fixed or static position, therefore it can be placed anywhere, and it is usually written as v is equals to xy or 2, 3 vertically. Now let's understand point form and line form graphically. So for that, let's take a point P as 3, 2. So in line form it will be v is equals to 3, 2 vertically. So in point form, let's plot 3 to the right and 2 up, and this point P as 3, 2 is a fixed point in this plane, whereas in line form V32 from the origin will give us V is equals to 3, 2, but this is not the only position of this vector. So like this vector V1 is also represent the same vector 3, 2. Similarly, V2 vector also represents 3, 2. So 3 to the right and 2 to the up. So each and every vector here, or these line segments, they are 3 to the right and 2 to the up. So position is not fixed in line form. So V is equals to V1, V2, V3, all are equal. So V1, V2, V3 all have same magnitude, same direction, or we can say that V1, V2, V3 up to Vn all are parallel to each other. So a vector in Rn is a vector in n space, and it is represented by an ordered n tuple x1, x2, x3 up to xn, where x1, x2, x3 up to xn belong to real number R, or the set of all ordered n tuples is called n space, and it is denoted by Rn. Like R1 is a set of all real number x, and R2 is a set of ordered pair xy where xy belong to real number. R3 is a set of all ordered pair xyz where xyz belong to real number. Similarly, Rn is a set of all ordered pair x1, x2, x3 up to xn where x1, x2, x3 up to xn belong to real number. For example, ordered pair 1, 2, 3, 4, 5, 6, 7, 8, 9 belong to R9, that is 9 dimensions. Similarly, ordered pair 0, 0, 2, 1, 5 belong to R5, that is 5 dimensions, or 5D, or here we can say 9D for 9 dimensions. So for a vector V is equals to V1, V2, V3 up to Vn, V1, V2, V3 up to Vn are called components of V, components of vector V. So now a vector, when one point is given, and suppose that point is Pxy, then in point form it will be a fixed point on a plane, whereas in line form there could be infinitely many line segments of the same magnitude and in same direction. Like here, V, V1, V2, V3 all are equal to xy and they have the same magnitude and they are in the same direction. So there is no fixed position in line form. Now when 2 points are given, so let's P x1 y1 and Q x2 y2 be 2 given points. Then let's plot these 2 points on the plane. So P x1 y1 and Q x2 y2. Now join these points to the origin. So we will get OP and OQ, and then PQ will be equal to OQ minus OP. So vector PQ is equals to OQ minus OP. Therefore PQ is equals to x2 minus x1, y2 minus y1, or PQ is equals to x2 minus x1, y2 minus y1 vertically, where PQ belong to R2, 2 dimension. So when PQ belong to Rn or n dimension, then what will happen? So these points will be P x1, x2, x3 up to xn, and Q will be y1, y2, y3 up to y1. Then PQ is equals to OQ minus OP. So it will be y1 minus x1, y2 minus x2, y3 minus x3 up to yn minus xn. So now let's find the vector joining 2 points P1, 2, 3, 4 and Q0 minus 1, 1, 3. So PQ will be OQ minus OP. So where OQ is 0 minus 1 1 3 minus OP is 1 2 3 4. So we will get 0 minus 1 minus 1 minus 2 1 minus 3 and 3 minus 4. Therefore PQ is equals to minus 1 minus 3 minus 2 minus 1. Now vector addition. Let's take two vectors. U is equals to U1, U2, U3 up to UN, and vector V is equals to V1, V2, V3 up to Vn, where U and V belong to Rn. Then U plus V will be U1, U2, U3 up to UN plus V1, V2, V3 up to Vn. Now after adding corresponding elements, we will get U1 plus V1, U2 plus V2, U3 plus V3 up to Un plus Vn. So this is how we do addition in Rn. And for a negative vector, that is minus U, we can write minus 1 times U. So for subtraction, we can write U minus V is equals to U plus minus 1 times V, and then proceed as we did in addition. Now scalar multiple. So let U be any vector U1, U2, U3 up to UN, where U1, U2, U up to UN belong to R. And let's take C, any scalar. Then C times U will be C times U1, U2, U3 up to UN, and C will get multiply with each and every element. So we will get CU1, CU2, CU3 up to CUN. Now let's take few example. So first for addition, vector addition, let U is equals to 1, 2, 3 and V is equals to 0, minus 1, 4 be two vectors. Then addition of these two vectors will be 1, 2, 3 plus 0, minus 1, 4. Add corresponding terms, we will get 1 plus 0, 2 minus 1, 3 plus 4, and we will get 1, 1, 7. Now let's subtract V from U, and we will get U minus V. And U minus V can be written as U plus minus 1 times V. That is 1, 2, 3 plus minus 1 times 0, minus 1, 4. And 1, 2, 3 plus, after multiplying minus 1, we will get 0, 1, minus 4. And now add corresponding terms, and we will get 1 plus 0, 2 plus 1, 3 minus 4, and we will get 1, 3 minus 1. Now for scalar multiple, let's take a scalar 2. Then 2 times vector U will be 2 times 1, 2, 3. Then 2 will get multiplied with each and every element of vector U. That is 2 times 1, 2 times 2, 2 times 3, and we will get 2, 4, 6. And similarly 2 times vector V will be 2 times 0, minus 1, 4. Now multiply 2 with every element, and we will get 2 times 0, 2 times minus 1, 2 times 4, and we will get 0, minus 2, 8. Our next topics are linear combination of vectors and special vectors. Thanks for watching.